Okay, good morning to all of you. See, today we are going to start with your remaining just one case of deletion in your singly linked list. Okay, and then we are going to see your next practical. We are going to continue with your next practical, that is implementation of stack using linked list. Okay, this one is left, delete node after a specified position, right? Before we discussed yesterday. Have you guys done the before part? We discussed it yesterday. Is it over from your end? Yes or no? Students, I am asking. We did before part yesterday. Delete before the specified node. Is it done from your end? Yes or no? What about rest of the other 5 people? Pranju, Shri, Darshan. Okay, Shri says yes. Fine. Rishabh, Jignesh Prasad. What about you guys? Done or not? Rishabh, the session is recorded. Okay. Honesty is appreciated, but just have a look where you are writing it. Oh, you are home quarantined or at hospital? Okay. Take care. Hope you recover really soon. Okay. So let's start with that remaining portion and then we'll go to our next practical. I cannot wait anymore for other students. Okay. Delete before the specified data is done. Fine. Now what we are going to do today, we are going to see for delete after. Okay, delete after the specified node. Fine. Now, just for the sake of discussion here, because we have seen delete before, okay, can you tell me what I need to do if I want to go for delete after? What can be the steps to approach this particular operation, delete after? What can be the steps? See, you have reference here. What can be the steps for delete before? So you need to tell me here, what can be the steps? You cannot think of any steps how you are going to approach this. If I tell you that we have to delete after a specified node, what is the first thing that comes into your mind? Exactly, very good Darshan. You have to take the data before which you want to delete. Okay, I told you, I gave you hint here that you can keep this one as your reference. Okay, data before which, okay, before which you want to delete. All right, let's say that data is again a num. Okay, inside a numeric value num, you are going to store that data. All right, so 30 is that data. 30 is the data given by the user. That 30 is the data after which I want to delete. So that means this particular node is our target node, or let's say 20 is the data, then your 30 will be your targeted node. All right, or 18, then 20 will be your targeted node. Okay, let's say 20 is given. Fine, so we are going to store here 20 in some variable. Next, what we are going to do next? We took the target data. Okay, 20 is the data after which I want to delete, so that means this 30, this is to be deleted. Now what I have to do? Divyajit, Divyajit, there or not? Tell me that first. Divyajit, okay. Shri, Shri is also not there.
Yes, ma'am.
Okay, you are there.
Yeah.
Shri, what will I do? I took the data from the user. Now, can you think of any next step? What I need to do? I took the data. Now, what I have to do? So you can have a look here. What I have done here, or what we have seen and deleted before. That's why I kept it side by side. What we have done here, Sri? Can you just see and tell me where my this cursor has been pointing? What we have done? See, you need to answer something. Either I don't know or madam I'm not getting.
Ma'am, we have checked the condition while PTR data is not num. Like uh, like this is the condition to delete before. Suppose in that example we have choose the number 20. So
Hmm.
it, if it is not equal to 20, it will iterate
So by
do
using that while loop, the answer is you are traversing. When I say what we are doing with this while loop, the answer is you are traversing. Why you are traversing in your single linked list? Because you want to reach that particular node. Okay? That is the answer. Absolutely right. Darshan, you are also right. We are going to take temp equal to head and pre-temp equal to temp. Okay. And Yasin, I suppose there are some network issues on your end because I guess rest of the students are able to hear me out. Yes or no? Can you hear me clearly?
Yes, ma'am.
Okay. So see, we are going to traverse here. Alright? Okay, no problem, Yasin. We are going to traverse. Okay? So that we reach here. Alright? Now see, which is our target node? Our target node is this. Fine. So if we see logically, without just going with the steps, if we see logically, alright, then I come to know, seeing this diagram, I'll come to know that right now this 20 is pointing where? At memory address 210. Okay, 210 is this. Now this memory address I am going to delete. So this memory address should be updated. Okay, so one thing I came to the conclusion that there should be one pointer here who can access this part of the node so that I can give the next of this. Okay, I can create this. Now to create this 240, this 240 is held by which node? This one, next of this node. Okay, which we are going to delete. So again I will have a conclusion that there should be one pointer here. Okay, who can access this part. So with the help of that pointer I can write here what? Temp of next. Okay, suppose this pointer is pointed by pointer temp. Okay, so it can access this part. So temp of next, which is 210 right now, I can update it with the value what? Equal to ptr of next. Okay, what is ptr of next? 240. So once this line will get executed, okay, then this pointer will no more point to this 210. Where it is going to point? It is going to point here at 240. Okay, it is not going to get linked here with 210. It is going to link with 240 because temp of next is this part, ptr of next is 240, so we are updating it with 240. Okay, so you are going to need two pointers here, one which is pointing to the node which is specified by the user, okay, that is 20, and one pointer which we want to delete. Okay, here you are not going to require three pointers. All right, so here your condition will be while ptr of data, okay, not equal to, or you can write yeah, okay, fine, ptr of data is not equal to num. Okay, this is your condition. What you need to do? Temp equal to ptr. Okay, ptr is equal to PTR of next. Alright. Before this, you have to take one more condition, that is temp is PTR is equals to head. Okay. Here one more condition I am writing, or just I'll write here. Before applying this while loop, you have to write this PTR is equals to head. Okay. Now if my PTR is here equal to head, so what is PTR of data? 10. 10. So that is my first iteration here. 10 not equal to 20, so true. So what I have to do with temp? Temp will be here. Okay. This temp will be here. What about PTR? PTR should move forward. Okay. So here's your PTR. Fine. Now again, second iteration. What is the PTR data? 18. 18 not equal to 20. Okay. So again, you are going to go inside this while. So this temp will move forward here. Your PTR will move forward here. Okay. Now see. Again, what is PTR? 20 not equal to 20. Okay, so this condition is right. But we want to reach till here, right? We want one more iteration out there, correct? So what we are going to compare? We are going to compare the temp data. Do you remember we had done this thing in insert after here? Sorry, not insert after here, insert delete. Yeah. Do you remember we were going with pre-temp first? Did we wait? Insertion in DLLs. Yeah, here. When we were discussing your doubly linked list insertion, you see the condition is what? Pre-PTR of data not equal to num. Okay. Pre-PTR equal to PTR and PTR of next. So what we are doing? We are keeping this pre-PTR in front of our PTR. Okay. So that condition value, see again, what is pre-PTR equal to PTR? You have to write here also. Okay. I forgot to mention that. Temp equal to PTR. Okay. And when you are comparing this temp value, alright, the temp will be one node ahead here. Fine. So I have to change a little bit my logic. Alright, we are going to compare the temp data. So obviously this temp is going to go ahead here. Okay, it is similar to your DLL insertion here. Okay, what we were doing here with pre-PTR and PTR, keeping pre-PTR forward. Okay, here is your PTR. We were keeping this pre-PTR here forward. It is same, nothing changed. Okay. So at the end, what will happen? PTR is here at the specified node by the user. Okay, temp will be at the node which is to be deleted. Now after completing this while loop, what you have to do here is you have to first of all update this value. Okay, this value you need to update. So it will be PTR of next equal to temp of next. Okay, so that is 240. Okay, so we created this link. Now we have to delete this part. Okay, this whole part is to be deleted. Let me just place it here. Okay, this whole part, if I delete, then this is the execution. Okay, PTR of next equal to temp of next, and for delete just use your free function. So free temp, okay, and then you exit. So that is your delete after the specified node. Got it? Or any doubt? Doubts, anyone? Okay. See, you have to keep your temp value. Let me just do it again for you. Okay. See, you have to keep this temp value ahead of your PTR. Okay. So one pointer, let's say you are taking PTR and pre-PTR. Fine, if you are comfortable with not temp and PTR, let's take PTR and pre-PTR. Both are at what? Pointing by head. Okay, whatever the value is. Alright, so you are going to write here PTR is equal to head. Okay, pre-PTR. Those who have understood, start coding. Pre-PTR equal to PTR. Fine. Now here, as you are doing in your doubly linked list here, while PTR of data not equal to num. Okay. This whole thing you are going to copy. The same condition. There is no change there. Okay. Both of them are your singly linked list. That same condition you are going to do. Pre-PTR of data equal to num. Now see, what is pre-PTR data? 10. So first iteration 10 not equal to 20. What it has to do? Pre-PTR should remain wherever it is. Okay, so pre-PTR remained here only. We are moving our PTR. Where your PTR is moving? Here. Alright, again your pre-PTR will check. What is pre-PTR again? 10. 10 not equal to 20. Okay, what we have to do now? It is true. So PTR will be here. Sorry, pre-PTR will be here. PTR is at 205. Okay, again check. Pre-PTR data. So that is 18. Okay, 18 not equal to 20. Okay, what I have to do? Move. From 18, pre-PTR will move to 20. PTR shall move to 30. Okay, now again it will check. 20 not equal to 20. Okay, so obviously this is false. So your pre-PTR, okay, is here. All right, and your PTR is here. Now we know that this is the node which we have to delete. But before deletion, we have to update this pre-PTR next, so that once we remove this node from between, this particular 205 node at 205 should point to node at 240. Okay, and this 240, that value is held by this node which is to be deleted. So before going for deletion, first go and update the link for pre-PTR of next. Okay, you have to update this link with what value? With the value 240. And because that 240 is held by this PTR value, PTR of next value, so PTR of next. Okay, so pre-PTR of next, that means 210, that is to be updated by the value 240, which is held by your PTR of next. So when you do this, when you execute this line, this link, this particular link, okay, gets generated. Okay, now what we have to do? We have to delete this PTR. So just call your free function. So free, inside that PTR. Okay, so when you call this free function, then this whole node will get deleted. Okay, and the thing that remains is what? This singly linked list. Now you check. The head is pointing towards the first node, there is a linkage between all the nodes remaining and the last node is null. So that means you have done your delete after correctly. Okay, any doubts here now? Anyone? Start implementing delete after the specified node. Okay, go and add it to your switch case. First of all, in your switch case, there should be a delete after. Okay, so in my program here, it will be case 7. Okay, give some meaningful name to your user defined function. Your break statement. Fine. Copy this and place it along with your other user defined functions. Okay, so this is my delete before, void delete after. Okay, now see, we are now familiar with that avail situations, right? So what you can do is, here you can write if head is equal 0. Okay, then what? Printf SLL is empty. You cannot do any delete operation. Otherwise, else, first of all, take the input from the user. So printf, enter the node value after which you want the deletion. Okay, scan that %d ampersand, let's say num value. Okay, and declare that num. Fine. Now ptr, or I have taken temp. What I have taken? Temp and pre-temp. Okay. So temp is equals to head, pre-temp is equals to ptr temp. Okay. Now what I am doing? Traverse to reach the specified node and node after it, or you can say the target node to be deleted. Okay, so while loop, while pre-temp of data is not equal to my num. Okay, what I need to do? Pre-temp is equal to temp. Temp is equals to temp of next. Okay, this much is done. Traversal part over. Once I reach the target node and the specified node, then temp of next. Okay, because why? Because my temp is going to be afterwards here. Okay, so temp of, wait, sorry, it will be pre-temp of next. Did I do some mistake? Else, okay. Pre-temp of next is equal to temp of next. Okay, what we did here, update the value, okay, of the node next part. Fine, this is done. Now call your free function. Inside that, what you are going to call in your free function? Your PTR, that means my temp here. Okay, so call that temp value. And you can also just tell your user printf percentage %d is the value getting deleted. Okay, and here you can write temp of data so that you can tell your user. All right, so this is your function. You are handling a situation, okay, that check first that your SLL does exists. Okay, so we are checking if head is equal 0, printf SLL empty. If this condition is false, then you go ahead with delete after. Okay, see, again I am saying, guys, kindly have a practice of writing comments wherever it is needed. Okay, if you don't write comments, it will be not helpful to you also, because you are dealing with so many programs. Okay, it is not just C language that you are dealing with. You are dealing with Python, you are dealing with maybe some another language in extra part if you are doing. Okay, and there are lots and lots of examples in programming language at a time you are solving. So when you come back, okay, due to one of the other reasons, when you are coming back again to see a program and these things are not written, okay, let's say it is something like this. All right, then what you are going to know, I have just written end of while here, something memory address is 6 and all, something like that. Okay, I have never written here what is this while loop doing, what this pretemp, why I am doing this pretemp of next and new node of next. Okay, so it will help you in a way that if you have written this in such a elaborated manner, that first check what SLL exists or not. So you'll come to know that this if else loop is doing part of what it is checking. Okay, we checked, now we went inside else. Now what we have to do, why this while loop has been written, so that I can traverse and reach the specified node and node after it. Okay, so you'll get to know. You don't need me. Suppose I am sharing this program, okay, and I have written my comments very accurately and correctly wherever they are needed. Okay, then you are not going to need me to explain it to you. Okay, and this is very helpful when you are going in your particular corporate life jobs, especially if you are targeting a job like software engineer or software developers. Okay, if you don't make a practice right now, then eventually in your companies you are made to do that. Okay, then it will be very difficult to have that. But if you are having the practice of writing, hello, am I audible to you? Okay, in my other device I guess the voice is not showing correctly. I thought I lost my network. Okay, nothing, you can mute yourself. I guess by mistake you unmuted yourself. Thank you. So that is what I'm telling. Okay, if you don't write your comments now, if you don't practice or cultivate that habit of writing comments now, eventually when you are going in your corporate worlds, especially if you are targeting software developers, software engineers, or software, uh, designers also. Okay, everybody needs to write the comments because there you are not just 4 or 5 people in the team. There is a team of around 15 to 16 developers at a time. Okay, and you have to integrate your modules. There you are not going to work only like this, only just one program. You are going to work on modules of the program, and then later on you have to integrate those modules. So while integration, okay, some of the variables have to make changes. So you have to know that at this place these things are happening. Okay, so to know that thing you have to write the comments, and that's why it is important to write the comments. All right, done, everybody? Okay, Darshan, it is working. Okay, just check your program, this whole program once again. Check all the functions are working or not, because we have finished this particular practical. Students, I'm giving you 5 minutes to complete this. Okay, delete after the specified data. Complete this, then we are starting with your new practical. Okay, Raj, if you have done, then just check once all the functions in your practicals. Sorry, of this practical, all the functions, all the 6 functions. Just check once they are working fine or not. You are getting issues in delete before. Show me your screen. I'm keeping this Excel file logic in front of you for others who are doing. Okay. All right. Good to know, Darshan. Really good. This is your delete before, right, Raj? Okay, yeah, got it. Just let me have a look. Okay, you have checked SLL exists or not. Then you are going for delete before. Then you are going for pre-temp equal to temp for the traversal purpose. Alright, pre-temp data not equal to val. Okay, temp of 0 is equals to temp. Pre-temp equal to temp. And temp equal to temp of next. Okay. Mm, fine. Temp of next equal to pre-temp of next. Temp of next or pre-temp of next. Okay. Getting muted free or pre-temp. Raj, just show me the working of this. You have forgotten somewhere some attributed value getting. Check your printf statements. Okay. It got terminated, no? Okay. Go to your delete before. Yeah. Do one thing. Mm, pre-temp is equal to temp. Okay, but you have not. Yeah, there is no starting point. How it is going to go for while loop? You have to give temp equal to head. Before you have returned pre-temp equal to temp, you have to give temp equal to head. Okay, so you will get the starting point. Then it will go for the traversal and then it will go and free the function. Let's see if it is doing it correctly. Go for 4 node values. Okay, still it is terminating. Um, do one thing. Write as I said. I guess there is some confusion regarding temp and temp zero and all. Do one thing, pre-temp and temp. Okay, yeah. Inside your while loop, The condition, the while loop condition. While loop condition. They are your while loop statements, dear. The condition for while loop to run, temp of data not equal to val. Take your cursor there. Yeah. Instead of temp of data, write there pre-temp of data. Okay. Pre-temp of data not equal to your value, then remove this temp 0 equal to temp. Remove it. Okay. Pre-temp equal to temp, temp equal to temp of next. Fine. Then outside, um, pre-temp of next, pre-temp of next equal to PTR of next. Pre-temp of next equal to temp of next. You have taken here pre-temp and temp. Okay, so take it as temp of next. Okay, and free up your temp, not pre-temp. Yeah, free up your temp. There also, printf statement, temp data is getting. Now try it out. Still there is some error. Do one thing, inside while loop, write a printf statement inside while. Let's see if it is going inside while or not. Okay. Done, it's okay. Just I want to see whether it is going inside it or not. It is not going. Okay. Have you given your temp and pre-temp value the global declarations? They are globally declared, yeah, okay. Is that so? Okay. Do one thing, try to print temp and pre-temp values before going inside while. Yes, their print temp and pre-temp values. Temp data and pre-temp data. They are pointers, dear, so you have to print their data. And percentage D will come, otherwise how it is going to print the data? Comma. Temp equal to head is not getting assigned. They are equal to, right? Temp is equal to head and pre-temp equal to temp. They are your equal to's, right? I cannot clearly see those. Yes, that only at line number 190, it is temp equal to head, right? Okay. The values are not getting itself attached to head. That's why it is not going inside while and it is not doing anything. And this cannot be happening actually. Try to print head data, printf.
Ma'am, in scanf he has not used ampersand.
Oh yes. Good observation, Vijay. Really good. Okay. Thirty is not before 20. Okay. Yes, the function went for delete after. Okay, go back. I got
Ma'am,
it. Go back.
ma'am, hello.
Yes.
In while loop, he use pretempt. In
Yeah. I got it. I got it. Instead of pre-temp, go for temp. Not there. Not there. That is okay. In your while loop. And just let me have a look now. Now I got confused. Wait. Delete before. Okay. Pre-PTR equal to PTR. PTR is PTR of next. Okay, that is done. And now update the values. Update the values with pre-PTR will be at back. PTR is in front. Okay. Oh yes, I told you this is before, right? So you have to take you have to take that third pointer. Yes, I was waiting for you to run the program. राज 20 से पहले डिलीट करना है ना. नोड्स क्या दिए थे? What is the node value that you gave? 10 and 20. 20 is getting deleted. So, okay, do one thing. Keep this program as it is. I will deal with this after I go with the next program. Okay. Rest of other functions are working. Okay. The thing is, we just messed up in this while loop, nothing else. Okay. I'll just make some changes in your while loop, and then we'll see it is going to work. You keep this function as it is. Okay. In the end, I'll take this function for you. Save the program, all of you. Okay, we are going for your next program. That is implementation of stack using your linked list. Okay, now see, here we are merging two concepts now. First concept is of your stack, and second concept is of your linked list. Okay, so before discussing that, I want to know how much you remember for that stack. Okay, so what do you understand by stack? Yes, students, what do you understand by stacks? Last in, first out. Okay. Anything else? In programming, if you want to implement that last in, first out, do you take any variables inside for the stack? The top variable. Correct? You are going to take the top variable. Alright? So see, there are some points to remember. Now see, in your linked list, what we are going to do? Your linked list has a node having data part and pointer part. Alright? So we are going to merge these two concepts. Okay, these two concepts we are going to merge, and then we are going to represent your stack, okay, in such a manner that you are doing all the operations of stack. What are the operations of stack? Can anyone list out the operations of stack? Push, pop, and one more. Peak. Yes, correct. Peak. Display and all is fine, but the major functions are push, pop, peak. Okay. So see, I'm presenting my screen again. Wait. There are some points you need to remember. Okay. And see, again, I'm telling we are merging two concepts. Okay. They are no more going to be those concepts which you have seen till now. We are merging two concepts. So there are some points to remember. Okay. For a linked representation of stack. The first point you need to keep in mind is what? We are now dealing with linked stacks, okay? Because we are implementing stack using your linked list, okay? Which is one of the application of linked list, all right? You can implement other data structures with the help of linked list. So this is the example here. So now I'm going to address it as linked stack. Okay. So in your linked stack, you are going to have two nodes. Okay. One which is storing your data part, another which is storing your address part for your next node in your linked stack. Okay. Now see, you have start pointer in your linked list and you have top variable in your stacks. What is start pointer function? It is going to point to the very first node in your linked list, right? And what is the purpose of top? It is going to point to that node which is newly inserted inside your stack. Okay, so we are going to merge this concept now. So your start pointer in your linked list, okay, is going to be used as top. So what that start pointer is going to do, it is going to point to that node which is newly inserted. Okay, because what is the function of top? Top keeps the topmost position inside your stack. So you can say the newly inserted node is pointed by your top. Okay, so that functionality will now be taken care by your start pointer. Your start pointer will be the one who is going to point to the newly inserted node inside your linked stack. Okay, so what can you say about newly inserted node? It will be your first node each and every time if you're going for insertion. Okay, then you are going to insert a node at the very beginning. Alright, you have seen to enter the node at the beginning of the linked list. Okay, so whenever you are going and inserting that node at the beginning of the linked list, that start is pointing towards that. So we are merging, see, we are merging those two concepts. Okay, the concept of top and concept of your start. Alright, so that is the second point you need to keep in mind. The third point, okay, all the insertions and deletions which are done are node pointed by your top. Okay, so that start pointer, you are now no more going to, address it at start pointer, you are going to address it as top. All right, and if top is equals to null, that means your stack is empty. That means for top equal 0, as you are writing head equal 0. Okay, in the same fashion, you are going to write top equal 0, then stack is empty. Okay, these are the 4 points you need to keep in mind. In your linked stacks, you are now going to have nodes. Okay, nodes having two part, data and the address part. The start pointer will be used as top. Okay, what is top going to do? Top is going to point to the first node in your linked stack, and that first node will be your newly inserted node. Okay, all insertion and deletion are done at node pointed by your top. Okay, so if you want to delete, you are going to delete the node which is pointed by your top. If you want to go and insert, you are going to insert it which is pointed by your top. All right, and if top is equals to null, you are going to indicate that your stack is empty. These are the 4 major points you need to keep in mind while going for your operations. Okay, let's discuss your first operation, that is a push. Now see, what are the steps for your push operation? Very first step, allocate the memory for new node and name it as new node. Alright. When I say allocate the memory, directly the programming line should come into your mind. New node equal to struct node star malloc size of struct node. Okay, when I say allocate memory of new node, alright, then this should come into your mind. Fine. Now step number 2, set new node data equal to val, our standard procedure. Okay, so you are setting the data part, so set new node data equal to val. Now check, if top is equals to null, okay, if top is equals to null, then the next part of that new node will be null. Okay, and top is equals to new node. So what we are doing here, stack, I'm writing stack underscore ll. Okay, now see, this is my nodes Let me just copy this. Okay. Yes, that is what the function we are going to do. Okay. See, this is my node. Okay, let's say the data part it is given. This next part is not given. All right. I have one top variable. Fine. That top variable is right now pointing at 0. Initially, as your head was pointing at 0 when you were creating that single linked list. Okay, the top was initialized to 0. Fine. Now what I have to do here? If top is equals to null, that means my top is equals to 0. Okay, so what I have to do, set new node next equal to null and top is pointed by your new node. Okay, so this first one, this here it is going to be null and top is equals to new node. So top value will be 100. All right, so what I did, I pointed my top, fine, to this node. Okay, this is my first case of push. Fine. Now see, if this is not the case, okay, if top is not equal to null, then whichever new node you have created, new node next equal to top. Let's say you went and created one more node here. Okay, this is the already existing case. Fine. You created one more node. It got memory assigned as 90. Okay, this part you have not yet dealt with. Data part you dealt and you said let's say it is 05. Okay, so now what I have to do, if my top is not equal to null, then new node of next is equal to top. So this portion, new node of next, this is my new node of next equal to top. What is the value of top? 100. So what I did, I shifted this. Okay, this got shifted. Fine, or you can say this particular node got placed in front here. All right, and when I say it is pointing to 100, okay, then what I did is actually I created one link between this newly created node and the existing node. Okay, this link got created. Now, as I said, your top is always going to point to the first node, right? So you have to move this top. So what you are going to do, you are going to move this top equal to new node. All right, so this top, you are going to move it. Okay, so top is now here. Okay, so top is equal to new node. When you say it is equal to new node, the value got updated to 90 and now this top is pointing here. Okay, so now you see what is happening. If we go and check the property of our single linked list, your head is pointing towards first node, the last node is having null value. So property satisfied. Okay, if we go and check with the property of stack, what does stack say about top? Top holds or points to that value which is newly inserted in your stack. So far, you have seen stack in this manner, right? This is your stack, okay, outer borders. All right, this is your stack. All right, if you go and insert, suppose you insert 12, then your top is here, right? Then you insert 15. Okay, then top position you increment first, then you go and add the value, right? So what is the purpose of top? It is pointing to the newly inserted node. So here also the newly inserted node is what? This one, and top is pointing that to that node. So we have satisfied that property of a stack also. Okay, so this is how we are going to do push function. Again, once again, suppose top is equal to null. Okay, you created a node and you came and checked that top is equal to null. That means your linked stack is not existing. You have to go and create it. Okay, so if that is the case, if top is equal to null, then only this next part will be x. Okay, then only that next part will be null. Otherwise else, if top is equals to not null, okay, is not null, then update this next part to the value of top. Okay, so you are going to create this link, fine, between the existing node and this new node. All right, and move your top back so that it points to now this particular node, which is your first node. You got it? The concept of push. Every time when you are doing push function, okay, the node is inserted here at the front and top is moved back, so that top is pointing towards your first node. So it is similar to the function which you dealt with insert at the beginning. You can compare it, right or wrong? Yes or no, students? Are you getting? Okay. Now what you have to do is create the node structure. Okay. The flow of the program would be create the node structure. Okay. Flow of your practical number 8. Okay. Stack linked list implementation. Fine. So first of all, create node structure. Okay. Second, declare your top variable. Okay. Inside your main. You can either directly call your push functions, okay, push, pop, and peep directly, or if you want to keep your program dynamic, which is the preferable way, okay, as many times as the user wants, then use your while and switch structure. So far we have done this, and you are very much now, you should be very much now familiar. Okay, give the option of push, pop, peep, and display. Right, and then start your push function. Push is a user defined function. Okay, so go and write the logic for that. I'm keeping this PDF open for you for that logic. Okay, this is your push operation logic. Start doing that function, start doing that program, everyone. You don't have any doubts here in the push operation, right? Nobody should be having any doubts. If you have, please do ask right now. First you guys try, then I'll show you in the program. Guys, anywhere if you are having any doubts, do not hesitate to ask, okay? And unless and until you don't try, you are not going to get what program is trying to, work, how it is going to work. So you are encouraged to at least try to write the program. You guys are able to do it or not? Students, anyone finished? Facing any problem? Facing any problems, anyone? Students, yes or no? See, I'm going to write the code now. Okay, for all those guys who are stuck somewhere or do not know how to do it, okay, this demonstration is for you. So you must have, included your standard libraries. All right. You also have to include your stdlib because we are going to use our dynamic programming here for assigning the malloc, I mean the allocation of the memory. So stdlib.h. Okay, so two standard libraries added. Now, first of all, create the node structure. Okay, so struct node integer kind of a data I want to store, and stop node star next. Okay, so my node got created. Now what I have to do, pointer variable top. So I'm declaring my top. Fine. So start top. Done. This much is over. Now what I have to do, top is equals to 0 initialized. Fine. Now void main. Okay. A while loop. For that I have to take some integer c and ch. Okay. C is equals to 1 already given. So while C, okay, my printf statement, implementation of stacked in LL form. Again a printf, or sorry, this is going to get printed every time, so you can just remove it from this position from here to here. Okay, now give a printf statement /n/t number 1 push operation. You can copy that. This is for pop, this is for peep, and this is for display, and you can give one exit also. Okay, so number 2 is your pop, number 3 is your peep, number 4 is your display, and number 5 is your exit. Okay, this exit is not mandatory, it is on you. If you want to give, it's fine. If you don't give, then also it's fine. Tell the user, choose the operation. Alright, whatever the user chooses, that you have to scan it. Store it in a variable ch, because that is my choice. Implement your switch case, passing your ch. Fine. Now your case 1, your push operation. So break. Right now I'm just writing a default. Printf invalid choice. Okay. End of my switch. I'm going to write printf one more time. Want to continue. For yes, press 1. For no, press 0. Scan your choice. Alright, so structure is ready. Now go for void push. Okay, that is a push function. Now, inside that push, first of all, what is the first condition that you need to check? If top is equal 0. Okay, so Wait, first you have to create the node, allocate the memory to the node. Okay, so new node. Now we are taking one new node, so obviously you need to declare it. So you can declare it here. Okay, comma, pointer, new node. Fine. So new node equal to struct node star malloc size of struct node. Fine. Okay, memory allocated. Now you can do one more check here. If memory is allocated, then only go forward, otherwise not. Okay, so if new node is equal 0, or you can write here if new node is not equal to 0, either of the condition, then go and do something about this push. Otherwise, else printf memory is full. Okay. Okay, all right. Now new node did get some value. Then again, check that node which is getting inserted is the first node. Okay, if that is the condition, then how we are going to check that? If top is equal 0, then what we are going to do in that case? In that case, we are going to do what? New node of next. Okay, new node of next will be equal to your null value or 0 value. Okay, and top is equal to new node. So this we pointed. Now here you have to write one more statement regarding your data part. So printf /n/n, enter the node data, whatever the data you get, store it in your new node data part, %d, okay, ampersand new node data. All right, fine. Then you are checking that is it your first node or not, which is to be inserted, new node next equal to 0. Okay, if it is not, then one more else new node of next is equal to top, wherever the top is pointing at, and move your top. Okay, so move it. So top is equals to new node. All right, that is what our that is what our algorithm says. New node of next equal to top, top equal to new node. All right, that is what we have done here so far. First, we went and checked new node did get some memory. Yes, it got some memory. So then go forward. And then while going forward, we again checked that if that top variable is pointing at 0, that means your linked stack is empty or not. Okay, if it is empty, then allocate this new node as your very first node and give the next portion as 0. This you have to take care. Okay, because see what we have to satisfy this condition that the last node in our linked stacks, okay, will be having null value. And as we are going for insertion mechanism as insert at the beginning, okay, so if it is the very first node to be inserted, then obviously this part will be null. If it is not, okay, if it is not the very first one, then you are assigning the top value, okay, and then you're moving your top so that it points it to this newly added node. So that is what the things are happening. Done everybody this particular program? Linked stacks, okay. Stack underscore ll. Save. Yes or no, done or not done? There is one warning or conflicting type of top previous declaration. What is the error with it? Conflicting type of tops. Okay, got it. Pointer top. Fine. Choose the operation number 1. Enter the node data. 56. Want to continue? Yes. Again, number 1. Enter the node data. 89. Want to continue? Yes. Okay, I have not given the display function yet. But 89 will be in front of 56. Okay. The display function will be same logic as you are writing the display for your link list. Okay. So just let me write here. What is case? Case 4. I didn't write here. End of while. Okay. Traverse. Temp is equal to top while temp of next not equal to 0. Printf percentage d slash d. Temp data. Temp is equal to temp of next. Again, write this printf so that last node data can be printed. Okay, and declare this temp. So choose your operation 80. Again choose your operation 100. Again choose your operation. See, 4580 printed. Okay. Students, did you get it or not? Yes or no? Display function is same as your linked list, Raj. Right now I have not, given that push pop P. So I'm just writing the code of display here after the end of my while. And this is my push function. Okay, everybody.
Ma'am, please just scroll up for one.
प्रांजल क्या देखना है?
Ma'am, that if part, I think I made a mistake. Got it, ma'am.
Okay. Done, everyone? Push function over. Yes or no? I don't get any answers from Harshvardhan or Dharmik or Netik, Preet, Darshan Manyar, Dhruvi. What about you guys? Yasin, can you present your screen? Okay, students, uh, can we go for next one? Then it is beep and display function is there only, so no need. Then there is change. Okay. Okay. See this pop operation now. We can go for this one. In this pop operation, what things are happening is your very step number one. Okay, obviously in your stacks also we were checking that if stack is empty, you cannot go for any pop operation. So that same thing you are going to check here. Okay, if top is equals to null, then print underflow, right, and exit from the function. Yasin, my voice is clear in my other device. Rest of the students, my voice clear? Okay. Okay, fine. If your top is not equal to null, that means there are some elements in the stack which you can be popped out. Okay. Then what you are going to do? You are going to take one temporary pointer PTR. So PTR is equals to top. Now what we have seen, what we have kept in mind, that all the insertion and deletion will happen wherever the top is pointing at. Okay, and that is what the concept of stack also says, LIFO, last in first out. Okay, so whichever the last value we added, okay, will be the first one to be deleted. So that last inserted value is pointed by your top in your linked stacks. Okay, so you are going to point that PTR equal to top and move your top equal to top of next. Okay, once you move that top to the next pointer, okay, then you are going to free up your PTR. So what you are doing basically, first of all, see in your stacks, what you were doing. Suppose I have added one more. Let's say I'm adding one more here. Okay, this is pointing at, let's say, 25 memory address. This is 25 here. All right, done. And data part, I'm giving it as 50. Fine. So this is my existing stack. Now here, previously what we were doing, last in first out. So when we went for pop operation, we took the value wherever top was pointing at. Okay, we decremented our top. Okay, so top is now pointing here. All right, and we used to say that this value 15 is getting deleted. All right, now see, 15 was the latest value in your stack. Here the latest value is what? 5. Okay, which is pointed by your top. So we are going to delete this. Now in order to delete this, what we are taking one more pointer, one more temporary pointer called PTR. Okay, so that PTR, okay, is also equal to 90. So PTR equal to top. Now what we are doing with this top variable, we are moving this top variable so that now it points here. Top equal to top of next. Top of next is what? 100. So this top value is getting updated. Okay, and this top is now going to point here to the second node, or you can say the node which was inserted before your newly inserted node. Okay, this before this top is now pointing at. Now what you have to do with this PTR, this PTR is taken so that now you can free up this. All right, now PTR is pointing at 90, so you are going to free this up. Fine. Once you call your free function, then what you have done actually, you freed up this value. So now PTR is not pointing to 90, it is pointing to null value. And see, you're still, the linked stack exists. Okay, satisfying all the property of your stack and link. Okay, so that is what this algorithm says. If top is equals to null, okay, you have to write underscore. Fine. If your link stack exists, then PTR is equals to top. Okay. You take that value of top, move your top to next. So the top is equals to top of next. Printf, element to be popped is PTR of data. Obviously, that element is going to be popped and free up that PTR. Okay, so that is your pop function. Take a screenshot of this and try it out. In the next lab, I will see your tries. Okay, take a screenshot of this pop operation. Done? We are going to conclude this session till here. Okay, everybody take a screenshot. Again, I'm saying concluding this session here only. We'll continue next week from here. Thank you all for attending the session. See you tomorrow. Okay. Yasin, you don't need to write your numbers. You are the only one from BD. AI students, write your numbers serial order wise. Once you write numbers in the chat, you are free to leave the session. Thank you all.
डिलीट वाला करें अभी नेक्स्ट टाइम?
हाँ राज, मुझे नेक्स्ट टाइम रखना है।
नहीं नहीं, आप जब बोलो।
हाँ अभी बस 5 मिनट रुक जाओ, इन सबको लिख लेने दो, रिकॉर्ड हो रहा है।
यस मैम।
Ma'am, I'm not able to
Yeah.
write my roll number, ma'am. And now it's okay.
Okay, everybody done? Naitik done? I hope.